We're going to determine if the series, the summation from 1 to infinity of 2 to the n plus 3 to the n plus 5 to the n divided by 5 to the n plus 9 to the n converges or diverges. And we're going to use the limit comparison test, which we'll abbreviate by LCT. Now recall, limit comparison test works like this. Suppose we have a series which we'll call summation a sub n and another series which we'll call summation of b sub n with the restriction that an and bn terms are positive for all n. If we take the limit as n approaches infinity of an over bn, and this limit is equal to L, and L is positive and finite, then either our two series, so a sub n series and the b sub n series, both converge, or the two series, a sub n series and b sub n series, both diverge. What we cannot have is an series converging and bn series diverging and vice versa. So we always denote the series we're examining by a sub n series. So summation n equals 1 to infinity a sub n is going to denote the series, the summation from 1 to infinity of 2 to the n plus 3 to the n plus 5 to the n divided by 5 to the n plus 9 to the n. What we have to do now is determine the b sub n series so that the limit comparison test will lead us to the solution. The way we're going to do it here is first look at the numerator. The most powerful term in the numerator, that is the term that grows the fastest, is 5 to the n. It eventually is going to dwarf 2 to the n and 3 to the n as n becomes very, very large. Similarly, in the denominator, that term is 9 to the n and not 5 to the n. So our bn series, we can try the following: summation n equals 1 to infinity of b to the n. Throw everything else away and keep the most powerful term in the numerator, 5 to the n, divided by the most powerful term in the denominator, 9 to the n. Of course, this is summation n equals 1 to infinity of 5 over 9 to the n. We recognize this as a geometric series. We worked with these before. Now let's take the limit as n goes to infinity of 2 to the n plus 3 to the n plus 5 to the n divided by 5 to the n plus 9 to the n, that's our an term, divided by the bn term, which we'll write as 5 to the n divided by 9 to the n. Let's do a little bit of algebra to simplify this and compute the limit. So the numerator will be multiplied by 9 to the n. We can write it like this. Instead of combining them, we can just write 2 to the n times 9 to the n plus 3 to the n times 9 to the n plus 5 to the n times 9 to the n. And the denominator will be multiplied by 5 to the n, so it's 5 to the n times 5 to the n plus 5 to the n times 9 to the n. Now we see here that, again, the most powerful terms in both numerator and denominator are 5 to the n times 9 to the n. Let's divide everything by 5 to the n times 9 to the n. So this becomes a limit as n approaches infinity, 2 to the n, 9 to the n, over 5 to the n times 9 to the n, so 9 to the n here cancel, plus 3 to the n, 9 to the n, divided by 5 to the n, 9 to the n, once again they cancel, plus 5 to the n, 9 to the n, over 5 to the n, 9 to the n, this is 1, always 1 for every n, divided by 5 to the n times 5 to the n divided by 5 to the n, 9 to the n, so we can cancel these two, plus 5 to the n, 9 to the n, over 5 to the n, 9 to the n. Again, that's equal to 1. So let's rewrite this after everything that we can be canceled. We have limit as n approaches infinity. In the numerator we have 2 to the n over 5 to the n. That's 2 over 5 raised to the nth power plus 3 over 5 raised to the nth power plus 1 divided by 5 over 9 raised to the nth power also plus 1. Now 2 over 5 to the n goes to 0 as n goes to infinity, because 2/5 is a number between smaller than 1 and greater than 0. When we keep raising these numbers to a higher and higher power, they get smaller and smaller and approach 0. Similarly, 3/5 to the n goes to 0 as n goes to infinity, and likewise 5 over 9 to the n goes to 0, and we're left with 1 in the numerator, 1 in the denominator. This limit is equal to 1. That is our L. It is positive and finite. So we can now draw the conclusion based on the limit comparison test. So let's write the two series next to each other. Summation 1 to infinity, 2 to the n plus 3 to the n plus 5 to the n divided by 5 to the n plus 9 to the n. That's the series. We want to know if the series converges or diverges. And next to it, we'll write the simpler series, summation 1 to infinity, and this is 5 to the n over 9 to the n, or 5/9 to the n. We recognize this series. This is a geometric series, and it is a geometric series with common ratio r equal to 5 over 9. Since it's less than 1 and greater than -1, this geometric series converges. We can actually figure out what it converges to, but we don't need that here, because now the conclusion we can draw is that this series, which is more complicated than the geometric series we were just looking at, also converges, and it converges by the limit comparison test. For more videos, visit www.mathprepvideos.com.